Hello everyone. Today we will be talking about ICP-OES, which is inductively coupled plasma optical emission spectroscopy. The basic principle behind the ICP-OES is the emission of photon having a particular wavelength by excited atoms or ions. In this technique, the energy for excitation of elements is provided from plasma. Firstly, let's have a look at some background. The energy levels in atoms are quantized. This means that between the ground and excited state of an atom, there is a defined energy spacing. When an atom is provided with enough energy from the plasma, its valence electron can get excited to a higher energy level. When the atom returns to its ground state, an emission of photon happens. This emitted photon has the energy equal to the energetic difference between the excited and ground state, which corresponds to a particular wavelength that will be specific for each element. For this technique, the sample should be either in the form of liquid or gas, because an aerosol has to be created from it. This is why solid samples require additional steps to turn them into an appropriate state. The prepared sample is injected into the machine. It is converted into an aerosol from which only smallest droplets are allowed to pass further. The spray chamber ensures bigger droplets are retained and don't cause inaccuracies in the measurement. The aerosol is passed to the plasma. Its high temperatures, about 10,000 kelvins, vaporize the aerosol. At this stage, the composition of the sample is broken down to three atoms that are then excited by collisions with the plasma. Sometimes the atoms can be even ionized, and then the ions can be excited. The excitement of atoms and ions leads to photon emission during relaxation to the ground state. The wavelength of the photons emitted by a specific species is characteristic for it and its quantized energy levels. This is why the element that emitted the photons can be identified. Additionally, the number of emitted photons of a particular wavelength increases when the concentration of the emitting species increases. Therefore, if a calibration curve is prepared, the amount of a given species can be quantified based on the spectrum. The detection limit is typically in a range of few ppb, so parts per billion. A part of the photons is focused by a lens or concave mirror. This ray passes on an image of the plasma to a wavelength selection devices, for example, monochromator. The intensity of photons at this particular wavelength is translated into an electrical signal that is then processed and displayed as a spectrum. The main advantage of ICP-OES is the extremely high sensitivity, down to few ppb, precision and accuracy. Other advantages include the high temperature of the plasma that allows for high efficiency of processes that lead to excitation. The technique is less noisy than others using such high temperatures for excitation and ionization and is better for liquid sample handling. It is also relatively inexpensive and easy to build. The source is electrodeless, which means that no impurities from electrode material are introduced. Additionally, more than 70 elements can be detected using this technique. One of the disadvantages of ICP would be the sometimes lengthy sample preparation, especially for solid samples. Moreover, to be able to fully benefit from the technique's quantitative part, calibration curves have to be made. This technique is used whenever a detailed elemental quantitative analysis is needed. Example would include analysis of catalysts, membranes, electrodes, batteries, and other inorganic materials. Sample preparation differs for different types of sample. The goal is usually to turn your sample into a not too concentrated solution. The example shown in the video included digesting the samples in acids. This process was facilitated by using a special laboratory microwave. These solutions were then diluted a specific amount of times. Moreover, calibration solutions were also prepared, consisting of the metals used in the sample with known concentrations. The solutions were transferred to centrifuge tubes and placed in the rack of the autosampler of the ICP OES machine. In our department, the ICP OES machine is operated under the supervision of technician. The results are provided in the form of a report with tabulated concentrations and weight percentages of different elements. Thank you for watching.